a transform. Update. Let's see. We want to calculate the forward-going vector. We want to calculate some forces. Forces. We will do a vector gravity, which is going to be setting object gravity. It's not clamped. Oh, okay. So we need to do like that. We have a gravity setting. Maybe we don't want to store it. I'm unsure. Yeah, it also needs the time step. There we go. The gravity just gets set every frame here in a vector. Then then if we want to increase our or rather add some force to let's see, new position. Yeah, the forward vector gets recalculated, right? Yeah, so if we are supposed to, we would like to be able to, well, we store the information here. Yeah, we could do, let's see. Yeah, Yeah, so usually you'd update the position by pulling off the gravity, but or the time step. So we could do something like gravity is equal to math scalar and pass in the old gravity and the time step and some factor. And then we have the time slice of that force for this frame. Um, yeah, so you could apply that directly to the position. But what if we jump? We would like something like a force vector of sorts. Which allows us to store different forces. So instead we are going to do forces and vector add scale vector. I need to change this naming. Let's see. So we pass in our forces, our gravity, and then our time step. So now we can actually update our position by adding this to our position. Let's see, we can update our position here. By we would like to update our forces with our forces. And no, this is not correct. So we take our forces, add them to our position, which is going to have this, but we will only add vectors together here. We will add this to our forces, and then we want to store our new position. Oh, I already had that. And then we want to clear the forces in a single instruction. There we go. So we want to do that every frame. Let's see how that works. It doesn't. Do I even call the method? I'm not sure. I do. We of course need to calculate the forces with our time step. Then we need to check collisions. Then we want to recalculate the transform and the bounding volumes afterwards. Okay, so yeah, I think the force here is probably way too high. We have no scaling in terms of mass. Yeah. Now we can add a force going upwards. Let's try to do that. M forces. is equal to, let's do 15 float. Let's do that. So yeah, something happened. It definitely didn't work as intended. Let's see. Let's do a very, very low part of the. So yeah, something happened here. It fell through the. Okay, let's position the camera, which is free floating first. So we will position it down here. Then I will try to jump on the character controller. Well, where did it go? Did it just fly off? Maybe it did. Well, oh yeah, we of course need to adjust the forces as well. Yeah, because we need to scale that as well. Math, scalar. We of course need to multiply that by our time step and then perhaps a degree of let's try to increase that. Okay, something happens at least. Let's see. Maybe not like times 10, maybe just. Let's see. We do like this. All right. We got jumping. We got jumping. And since we have no mass here, let's see if we, yeah. Well, afterwards, let's see, we store the forces and they do get applied every frame. I think there might be something in terms of how we do stuff, but because as you can see, everything is fine here. I mean, fine and fine. The gravity is not great. Uh, and we can, of course, do infinite jumping. Yeah, I'll do a short check on how to handle. Yeah, let's just stand up here. Okay, the camera movement is really, really bad. We need to handle camera updating as well. All right, let's see, recalculate the transform. Yeah, we don't update the camera position. I think we will do that is in a separate function, recalculate calculate camera as the final private method, since we're gonna do it. Okay. Well, this is some specific stuff. Well, the new position does get stored inside our camera, so we might get away with moving this, and then instead of new position, we will just take our transform that position instead. Let's see. The position. Yeah, okay. So we need to call the math library. Please give us a vector. I think it's load float. Yeah. There we go. Please give us a vector of this transform here. Let's see. 1 minute, 2 parentheses. Well, we don't want to do it every time, or rather 2 times. Just a habit of rebuilding everything. So right now we have separated our logic in terms of updating the camera. Let's see if everything just works. It works. And let's enable the first person camera. The last thing is, of course, to disable jetpack mode. Even though it would be fun to perhaps have an jetpack mode. It's sort of like Duke Nukem style. Yeah. But so far so good. Inside our jump method, we can do a comparison. We could do something like do we actually have a way of getting a SIMD Boolean equal? Compare equal. Single boolean, you can do like this. Okay. Yeah, so this sets it to true. Let's see. So we can implement this in our own way here. So we check. Let's see, we could compare it to. We could either do it collision based, where if we collide with the floor, we could kind of unallow this force accumulation. We could also just check if, well, we reset it every frame after we're done with the forces. But we do add it in again, so the old forces does not get, or rather no, we do reset it. Let's see. We could do a check here. If we suddenly have a force that is different from gravity, in terms of downward going motion, we must be applying a force upwards. And since we're doing that, we might simply unallow it. Or maybe just set a flag that we are flying. Yeah, maybe we do it that way instead. So for now we add some force by pressing space. Down here, just to vector compare PS, I think, yeah, compare gravity and let's see, we store whether they are equal, and for now we just let's see, if the mask is equal to every 4 bits set, or rather 4 bytes set, we just dump it in our console. Only gravity applied, and we just do something else here. Something else here. Something else here. So it doesn't think that the forces are equal, which is because it's equal to 0, of course. I need to, yeah, of course. This is not great. After I apply the gravity, maybe we just want to scale this beforehand, and we want a and then we just vector add, and instead apply the already scaled gravity. And now we can compare. If our gravity scaled is equal to our force, generally speaking, scared, okay, we're not entirely correct yet in terms of Oh yeah, we also have a time step here in terms of the forces. Let's see, maybe if we do like this, it's not gonna work properly right now. We need to do m forces is equal to vector scalar m forces, and then the time step. We do that afterwards. So now it should. No. Okay, yeah, it's not definitely not working. Let's see. What did we do differently before? So does this work as intended mechanically? Yeah, it does. And we just added a bit. Let's see. Should we dump them so that we can debug it further? Gravity. Let's test that. And then forces, just to compare. Right now I know it's definitely not equal. Anyway, gravity, oh, they are equal. But if, let's see, whoops, too long for the physics to handle the pause. So let's just try that, and then yeah, it's not gonna work anyway. I think whenever I press the button, let's see. Whenever I press the button, do they differ? Yeah, they do differ. Something else. They definitely do differ. But our checking here is not really working. Let's check our compare equal. And then not a number. Yeah. Move mask. Let's do a dumping of the mask as well. 15. Let's plop that into our calculator. Program at 15. So it's basically saying that all bits are set. Let's do, yeah, it's our Boolean checking here. So only gravity applied. That is the reason why. Well, no. So this, yeah, it changes 13. It changes the bit mask. Yeah. That is weird. Let's disable some of this because it just spams the console. So only gravity applied, but as you can see, it does find a difference. Let's see. Bitwise and operator. Let's see. Let's see. Yeah, this is not correct because some of the bits will be the same, and therefore the result is, and it's not going to be equal to that. Maybe we do. No, that's not. Maybe it is. No. Let me see. I'm so rusty in terms of doing bitwise operations. So, let's do bool debugging here. Bool is 15, 13, yeah. I mean, we do get some information. Maybe we do. Let's see. It's never equal to that if I cast it. Let's do, yeah. maybe uint 8 on this system. No. We could just do the integer value. If it's 15, everything is in order. Yeah, as you can see here. Let's see. We do a flag jump it. Let's see. Yeah, this is not a good way to do it. I suddenly realize this is definitely not a way to do it. If definitely not, it's not gonna work. It's gonna do something weird. Yeah, we can't even jump now. Yeah, of course. If we're not jumping, we add the force. If let's just let's see. Jumping. I mean, this is going to suck. So yeah, it does print it whenever. Flag. Let's see. Yeah, as you can see, we're getting this weird effect here, where whenever we're in between frames, we can add some jumping. That's why I said that this system sucks. We won't be doing that. Let's just do a simple player check here. We could do we could store a in the y coordinate for last frame. Instead, we could, yeah, we could do that. Float last y. And then we could do We check up here if last y is higher or lower than or equal to our transform position y, then we must will not be falling. If it's above the, we shouldn't be falling. This just definitely doesn't work. Oh, it's because whenever I update it, I need to. Yeah, this is not the place to set it. It's before I update the position. So there we go. Right now it will always be the same. We do it. Well, this isn't working either. Maybe let's see if there's any difference. If it's like 0. Yeah, maybe because if it's maybe larger than less than. No. Okay, okay, okay. I have one last resort, I think, and that's we can do some iteration over the contact normals. Const auto reference normal in contact normals. If any of these contact normals are in a upward going motion, we must be standing on something, and thereby we can set the flag grounded. We're just standing on something. Yeah, since gravity will be pulling us downwards every frame, we can check for that. Let's see. We do not want to set a last y. Let's see, and we will do some checking here. We will compare the normal to our upwards going motion. And if the mask is equal to that, we must be grounded. Let's just print it out. We're grounded. Sad face. Pun intended. Let's see. We're grounded, sad face. Right now, we can't jump because I removed the if grounded and forces equal to, let's do like that. There we go. Um, let's see. It knew when we were grounded, at least. And maybe we want to set the flag here afterwards, of course, because we suspect we're not grounded. It will get reset if... okay, that's more like it. Now we only apply one force. You might not see it, but we actually do some jumping like motion, and we made a massive leap. And I can't reapply it unless I'm standing on the ground. I think that will be let's see. Yeah, it's definitely not as nice as I hoped. And that's a lot of force. Let's see. Uh, mm, and we should probably break then, because we don't want to. It's really not nice. It's kind of a stupid, weak ass jump. For some reason, I mean, uh, this is freaking janky. Oh, this is so janky. Let's do some time step manipulation here. That might be what we're experiencing. Are we applying the time step as well down here? Yeah, we are. Yeah, it's definitely not nice. Yeah, we don't want the time step. Now that is some quality content. For some reason, I mean, well, maybe we don't set it here, but we set it here, and then we prove I can't jump again. For some reason, maybe it's the way I handle the gravity. Uh, so we add our force. This will be way too fast. Yeah, we will just drop through the floor. Let's see. Maybe it's because I get pushed off the floor. Yeah, it's probably that. I get pushed off the floor every frame, and then every other frame we're not grounded. Let's just if we're not already grounded, and then we swap it back here. It's maybe because we just do it in the wrong steps. Oh, wait a minute. Maybe I do it before I resolve the positions. No. Yeah. Mm. I mean, I can't jump while I'm in the air. So that's great. But it definitely doesn't understand. Maybe if I just wait long enough. Yeah. It's when it's applying gravity. The longer I wait, the more I can jump. Or at least so it seems. But sometimes at random time steps, maybe it's frame related. Yeah, maybe it's frame related. Maybe I scaled this wrong. It also feels unrealistic that I can actually just move around in the air. This jumping mechanic is not great. I think we should do something like, yeah, you can't change course as well. Maybe, yeah, we could do some checking here. If we're grounded, we can move horizontally. Yeah. Yeah, I think I need to do some more proper vector math. Yeah, I think I want a velocity vector on the system instead. So, yeah. Let's do a velocity-based system instead. I mean, this really sucks. It just updates the position. Yeah, maybe we do integration as the last part of what we do. So if we look at the particle uh, integration here, we can simply just copy some of the logic. We will do a renaming of some of it. We're in the player controller here. Let's see. We will just copy it in here. And make it work better. Way better. Uh, uh, so we integrate by, let's see, calculate camera, bounding volume, transform. That is something we like. We want a player controller. Instead of doing that, we will do a movement vector. Or just a velocity vector. We will disable this and revisit the code. We will delete that for now and revisit this code. We want to add to our, instead of calculate forces, we would like a update, or rather integrate movement, and we will take a time step for that, and we will call integrate movement here with the time step. We do check collisions afterwards and correct them. We could skip this for now. So inside our integrate movement, we will do the same thing as we do with the particles. And where did it put it? It put it here. So we do in terms of let's see. Yeah, we need to stop doing this and this, and we want to inside our integration here, we want to do some new position stuff. And that way this is sort of like updating, just split in two. Store float, transform position is a, yeah, so we can do transform position here and math load float, a reference to our position and our velocity and our time step. All right, that is our new position, which we store in the end. Then we do the same thing as up here. We apply some physics, gravity, which is going to be our total velocity. Let's see. This is going to be the total force that gets applied every frame, not flame. And we of course need to do some dampening as well. Anyway, we will update the velocity by adding the total gravity for the time step. Now we apply gravity, then we apply some drag. Since we're not, maybe we do something like 0.5 at least for now. And that is basically it. We update the velocity and then we update the position. We apply drag, which means that our movement will not will not go on indefinitely. This is disabled right now, so we don't care about that. We want a horizontal movement to simply add to our velocity since we update it every frame. So let's see. The velocity gets added together with the movement, some movement on the right axis. Then we do the same here, or rather, let's do it on the forward vector instead. There we go. We recalculate the forward vector every time. Let's just move this so we can see what the old code is. So let's see, we update the velocity whenever we try to move during our integration, we update our position from our velocity, we apply some drag. Let's see, yeah. So now we have let's see. Yeah, last thing is we want to clamp the velocity of sorts. Yeah, we still do some grounded checking, but now if we are grounded, we can set grounded to 0 until we hit the ground, and we can add some velocity. Vector add the old velocity and just some new velocity where we add a y component, and now the old thing doesn't get overwritten. And as you can see, it works, and I can't hold the jump key down. So this is way better. Last thing is I do not want to be able to adjust the movement here. So yeah, we basically revamped the so yeah, I can run around, but I can't affect the jumping direction whenever I actually jump. This is a way better system. The only thing I need is to kind of manipulate how we apply velocity and kind of cap it. So yeah, finally we are done. Let's see if we can jump up on this guy's head. We can, but I couldn't stand there. Okay, I'm bad at this movement system is not great. Uh, it's really hard since I can't break in the air. Yeah, maybe we'd want. Well, because we're having a bounding sphere, I think it will push me off. My base isn't square. Well, now I can jump again. Okay, so this proves that the system actually works. No matter what I stand on, I will be considered grounded. Yeah, and I can run straight into a wall. Yeah, I think if I enable vsync again, we will probably, maybe it's our sampling, but there were some weird artifacts there. Maybe it's the streaming, I don't know. Let's enable vsync. I think it helped a bit. Yeah, and anti-aliasing and everything would, of course, do more justice. Okay, great. The last thing is some minor adjustments to the movement system. As you can see right now, it works almost as intended, or rather, it works as intended, but it could use some modification and clamping. Yeah. Maybe we want some minor vertical braking. Maybe we imagine that our character was able to kind of do something to uh, counteract the jump. As you can see here, yeah. Maybe it just needs to be something very minor. So that we can brake a bit in the air. Yeah. Maybe? Maybe actually it's nice to have a bit of control over the character while he's in air. Maybe this is something general we'd like. We would definitely not like to be able to jump much further, but maybe the controls feel better if if um if it kind of uh, if it kind of allows you to move just a bit, tiny bit while you're in air. I mean, it's not realistic, but it might be more fun in terms of gameplay. Let's see. We actually do not calculate the forces anymore, uh, since we just do integration of movement, like in physics. Check collisions, calculate forces. We're actually kind of done. The only thing we need is we need to modify slash improve the movement system and the feel of it. We need to clamp the max speed. So we calculate the forward-going vector. Actually, we could just maybe we I'm sorry. Hiccups. Um, we might want to I think this will only happen once per frame. We might only want to recalculate the forward-going vector whenever we use it. Because we use the right vector to handle strafing. Yeah. But that is it, I think. Only minor adjustments here. And you'd want to do some clamping of the max velocity in either direction. Maybe we want even more drag. This feels a bit sluggish. What if we do not apply any drag at all? Yeah, we end up with a lot of velocity left over. We can't even move in the other direction. The problem is that it kinda builds up to this vector where we apply different forces, sort of. Maybe you want a lot of drag, but maybe a higher interval in terms of the actual velocity, meaning that we do bigger steps, but we get more drag. And then we clamp it. We could also do a sort of combined system where we do velocity based jumping, and then we do old school positioning. Let's see. We could try that so that our velocity only handles upward going motion. Is that yeah, it's the one with the forward vector, and the old one here is, yeah, let's test that out instead. Simply do everything that has no physics feel to it. Maybe we do yeah, this is let's see. Maybe we want to try just adding vertical, and yeah, this feels weird. It feels really weird. feeling like everything is so sluggish in the forward going direction. And then let's see. Yeah, and then and we do maybe change this. And maybe we do jumping. Move vertical. Move jump. Let's do an amount and a time step. Calculate forces is gone. Let's create that. And we do some jump, move jump. Let's do 20 and a time step. And then we want to calculate the foregoing vector. And we want to sort of add something to our velocity. Let's see. We want to add our old velocity, but we also want to add our, maybe we do math, vector add m forward, and then our amount here. Or what? Yeah, so we scale this forward-going vector with and add a y component, which will give us a forward-going vector that we kind of scale afterwards. Let's see. We scale it too low, I think. Maybe we want to scale it by 100 to get a starting point. Oh, okay, that's way too much. Maybe we want, well, that's way too much. We can adjust the, maybe we just want a unit vector to be added. Maybe we want more. Yeah, so we kind of jump forward whenever we do it like that. Let's add some more forced oomph to it and then add a vector that goes upwards. Well, that's way too much. We also increased the other factors, so maybe it doesn't feel smooth, but yeah, so there's kind of like that, and then we do not use the velocity in terms of moving in that direction, so maybe we want a lot of dampening. Let's see, where is our dampening? Integrate movement, yeah. Let's do a lot of dampening. Maybe not so much dampening, let's try that. And the vector keeps on going, so that's definitely not the solution. Let's see. Uh, and then if we scale this down, maybe that's okay. I mean, it almost feels kind of natural. And you could always scale the forward-going vector by a different amount. So for instance, scalar multiply scalar, maybe we want the forward-going vector only to affect this motion by half as much, and we would like to go, wait, that's a bit too high. Let's revert it back. For some reason, it really, the first time, I mean, if we wait, or if we just, so this is the, I don't know why, maybe it's because the vector gets initialized as 0, or there's a large discrepancy in terms of um, uh, because the first time we jump, oh, it kind of adds up. It ends up being multiple jumps. didn't realize we have so many frames per second. Whoops. And our physics step needs to be continuous to be able to register. Let's see. Whoops. Yeah, so this actually happens for yeah, but we can't do any angle jumps. Let's see. We might want to add some horizontalness to it. Can we? Well, yeah, there are many ways to play around with a movement system like this. So the jump, yeah. Does it work that we just jump ahead or whatever we're pointing at? It just feels like a real jump, but I'm not sure that I actually like it. Let's increase this in terms of how much it affects the actual jump. Yeah, maybe we just want to use it as is. Yeah, for some reason, sometimes it just blasts off into oblivion. Maybe it's because of the time step or something. Oh, I have to have a short break here. I'll end the YouTube video and I'll end the YouTube video here. Hopefully you found it helpful, insightful, or something alongside that. Hopefully I'll be seeing you around. Bye bye.